Alright, in section 6.3 we're going to talk about scientific notation. And our definition of scientific notation is that it is used to write very large or small numbers. So it's an easier way to keep track of the place value of our very large or very small number. In order to write scientific notation, the way we're going to write it is with some number a, we'll just call that some number a, times 10 to the n power. So we are going to fill in the a and the n, our variables, with some numbers. The steps to writing scientific notation come in 4 parts. So our first step is to move the decimal after the first non-zero digit. Next step is to find the power of 10 by counting the number of times that decimal is moved. Next step, when the number is greater than 1, the exponent of 10 is positive. When the number is between 0 and 1, the exponent is negative. Okay, so now that we have our steps written down, let's look at a few examples down here. So number 1, we have 2 times 10 to the 5th times 3 times 10 to the negative 8th. So the first thing we're going to do is multiply our numbers together. So we have 2 times 3, which gives me 6. And then when I multiply my two 10s together, my 10 is a like base. So I'm going to have times 10, and I'm going to add the exponent. So I have, let's try that again. 5 plus a negative 8. So now I can simplify that. That's going to give me 6 times 10 to the negative 3. So this is our scientific notation. If we were to write that number as a regular number, you're going to type that in your calculator, 6 times 10 to the negative 3. That would be 0.006. This is what we call standard notation. So if you notice, if we look at this number, 0.006, if I move that decimal point after the first non-zero number, so that would be 1, 2, 3, that's where I get this 6 from. And my 3, 10 to the third, but that negative is because it's between 0 and 1. So that's where I get the 6 times 10 to the negative 3 from. Okay, let's look at number 2. Alright, for this next example, I'm going to start with standard form this time so we can see how we get our scientific notation. So if we start with standard form, when I multiply these two numbers together, I get 0.000. See, we've got 5 zeros. Then 595. So this is my standard. I want to move it to scientific. So step number 1, I'm going to move my decimal over until it's after the first non-zero number. So we got 1, 2, 3, 4, 5, 6 places right here. My next step is to find the power of 10 by counting the number of times my decimal is moved. So I just did that. That is 6. When the number is greater than 1, which it's not, right? This decimal is not bigger than 1. It's between 0 and 1, so my exponent's going to be a negative. So my answer here is going to be 5.95 times 10 to the negative 6. My scientific form. Okay, let's look at number 3. Okay, for this example, when I type this into my calculator, I get 30,000 in standard form. But remember, I'm looking for scientific form, so I need to move my decimal over so that I only have one number out front. So if I have my decimal right here right now, I have 30,000. I'm going to be moving it to the left this time. 1, 2, 3, 4. 4 places. So I'm going to have 3 times 10, and since my number is bigger than 0, I'm going to have a positive exponent. That gives me my scientific notation. Okay, number 4. When I type this into my calculator, my standard form gives me point. Let's see, how many zeros we've got? 1, 2, 3. 10 zeros. And then a 5. So this is my standard form. And as these numbers get bigger and smaller, you can see that scientific notation is going to be a lot easier to write than having to count out all these zeros. So if I go to move my decimal, I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places to get that 5 out front. So I'm going to have 5 times 10, and now since my number is smaller than 0, or smaller than 1, between 0 and 1, I'm going to have a negative exponent. And that is my scientific notation.